So
today we are going to start with the intermolecular forces. So what are basically
yes,
intermolecular forces? For example, if I talk about HCl molecule, hydrogen chloride. So what happens that hydrogen and a chlorine covalently bonds, and as a result this molecule is formed. Is this understandable? In
yes,
the
sir.
there are multiple molecules over there. So what happens if you see this molecule gets partial positive and this molecule part of the molecule gets partial negative. So the opposite charge, this end of the two molecules start attracting each other. And this attraction, which is actually exists between the molecules, this force of attraction is called intermolecular force. Is this understandable?
Yes, sir.
Okay, so if I talk about ionic bond, it is between ions. If I talk about metallic bond, it is between cations and free moving
If, uh,
electrons.
free electrons.
If I talk about covalent bond or a dative bond, it is usually between atoms to form molecules. And when I talk about intermolecular forces of attraction, it is between molecules. Is this clear?
Yes, sir.
My last point, yeah. So if I categorize intermolecular force, intermolecular force is actually divided into three categories. One is called instantaneous dipole-dipole forces. It has more names as well beside this. It is also called temporary dipole-dipole forces or van der Waals forces or induced dipole-dipole forces. Second one is called permanent dipole-dipole forces. And the third one is hydrogen bonding. Okay.
Okay.
So now, yesterday we have categorized molecules on the basis of polarity into two types. One are polar molecules and the other one are non-polar molecules. Are you now able to figure out, if I give you an example, you can figure out whether that is a polar or a non-polar?
Yes, sir.
Okay. So the molecules which have no net dipole, it means the molecules which are non-polar, these molecules, between these
Mm.
molecules, the intermolecular force is this, which is either you call it instantaneous dipole-dipole force or induced dipole-dipole force or temporary dipole-dipole force or van der Waals force. Okay.
Okay, sir.
And the molecules who have permanent dipole means who are polar molecule, the molecules which are polar, they have a permanent dipole-dipole force between them. Is this clear?
Yes, sir.
Okay. Now, when we talk about hydrogen bond is very specific. It is it is for a specific molecules, and you have to understand and remember that condition to know whether the molecule has hydrogen bond as an intermolecular force or not. So that condition is this, that in that molecule, which is going to form a hydrogen bond, must have a hydrogen in it first. And secondly, that hydrogen is bonded to either one of the atom among these. Whether that hydrogen is covalently bonded to fluorine, whether that hydrogen bond is covalently bonded to this oxygen, or hydrogen is covalently bonded to nitrogen in a molecule. Is this understandable?
Yes, sir.
And that hydrogen, which is actually bonded to these three atoms, if attracted by fluorine, oxygen, or nitrogen of another molecule, then that attraction is called hydrogen bonding. For example, if you see this is a one molecule, and in this one molecule there is a hydrogen, and that hydrogen has a covalent bond with fluorine or oxygen or nitrogen, right?
Yes, sir.
And this hydrogen is attracted by the fluorine or oxygen or nitrogen of another molecule, then this force of attraction is called hydrogen bond. Understandable?
Yes, sir.
Okay, so if I talk about the strength of the intermolecular forces, so the most stronger intermolecular force is hydrogen bonding. Then we have a permanent dipole force, and the last or the least strong is induced dipole force or the temporary dipole force. Clear?
Yes, sir.
Okay. Now we have to understand factor affecting the intermolecular forces. So remember, when we are comparing the, for example, I have one molecule this, and I have another molecule this. So between hydrogen molecules, which intermolecular force will be there?
Mm. Induced dipole.
Very good. Between HCl molecules, which intermolecular force will be there?
Permanent dipole.
And if it is HFC, hydrogen is bonded to fluorine. So which intermolecular force will be there?
Hydrogen bonding.
Hydrogen bonding, very good. If there is a H2O, hydrogen is bonded to oxygen. So in this case, there is a hydrogen bonding between the water molecules. In the same case, between ammonia molecules, there is a hydrogen bonding between the ammonia molecules. It is because in ammonia, hydrogen is bonded to nitrogen. In HF, hydrogen is bonded to fluorine. And in water, hydrogen is bonded to oxygen. So between these molecules, there is a hydrogen bonding. Is this clear?
Yes, sir.
Okay. Now, for example, if I have a carbon dioxide molecule, if you recall from the last class, carbon dioxide, the bond is a polar, but due to the linear shape,
The cancel
they cancelled
out.
out. As a result, the molecule have no net dipole, right?
Yes, sir.
So it means it also has an induced dipole force, right?
Yes, sir.
Okay, now it is very obvious if I say hydrogen has induced dipole force and HCl has a permanent dipole force. So HCl has a stronger attraction between the molecules as compared to hydrogen because of the difference in the intermolecular force, right?
Yes, sir.
But if I have a two molecules which have a same type of intermolecular forces between them, then we will see the factors to understand which one has a stronger intermolecular force. Is this clear?
Okay. Yes, sir.
Okay. So here we have a factor. First is the nature of the molecule. As we have discussed it, we are able to figure out that which kind of force between the molecules. If we know that there are two types of molecules, one has a induced dipole and the other one has a permanent dipole. So it's obvious that the permanent dipole has are the stronger intermolecular forces. And for example, if I have two molecules, one has a hydrogen bonding and the other one has a permanent dipole. So it's obvious that hydrogen bonding is more stronger than the permanent dipole force. So from the nature, we can figure out which one is stronger. Is this clear?
Yes, sir.
Okay. Then second, the number of electrons are very, if the two molecules, if the two substances have a same type of intermolecular force, as I have given you the example of carbon dioxide and hydrogen, or let's say take the example of carbon dioxide and chlorine. Both have induced dipole force of attraction, right?
Yes, sir.
So what happens in this case, we will go for the number of electrons. We will see which one has a more number of electrons and protons. So the greater number of electrons and protons leads to the stronger intermolecular forces. So if we look carbon, the atomic number of chlorine is 17. So there are two chlorine, which means there are 34 electrons over there. In carbon, there are 6 electrons, and in oxygen, there are 8 electrons. So 6 plus 16 gives me
22.
22, right?
Yes, sir.
So see, it has a lesser number of electron, it has a more number of electrons, so it means chlorine has a stronger forces than the carbon dioxide because there are more number of protons and electrons. So the induced dipole forces in chlorine are stronger than the induced dipole forces in between carbon dioxide molecules. Is this clear?
Yes, sir.
So see here I have got the comparison. Fluorine has a 9 electron, chlorine has a 17 electron, bromine has a 35 electron, and iodine atom has a 53 electron. So these all exist as a diatomic molecule. So in this way, fluorine molecule has 18 electrons, chlorine molecule has 34 electrons, bromine molecule has 70 electrons, and iodine molecule has 106 electrons. Is this understandable?
Yes, sir.
Okay. Now, all of them are non-polar. They don't have a known net dipole. So it means all of them have an induced dipole forces of attraction, right?
Yes, sir.
But due to the number of different electrons, when we move down from fluorine to chlorine, chlorine to bromine, and bromine to iodine, as the number of electrons are strong, are getting greater, so the strength of the induced dipole forces would increase, and as a result, we will observe the difference in their states at room temperature, as fluorine and chlorine are gases, bromine is liquid, and iodine is solid, which indicates that between the molecules, the forces of attraction getting stronger. Is this clear?
Yes, sir.
Okay. Now, the second factor is more number of contact points between the two molecules. If the one has a more number of contact points between the molecules, it has a more stronger intermolecular forces. For example, if I take C, both have a same molecular formula, which is C5H12, isn't it?
Yes, sir.
So, but this structure is linear and this structure is a branched one, right? So due to the linear structure,
Yes, sir.
two chains come closer to each other at many points. And here, the two chains or the two structures due to the branch one, they come closer and they start interacting with each other from only 2 points. But here there are multiple points by which they are interacting with each other due to the linear shape, right?
Yes, sir.
So it means that its intermolecular force of attraction is going to be stronger than this one. Due to this, it has a high melting and boiling point, and this one has a low melting and boiling point. Is this clear?
Yes, sir.
Any confusion till here?
No.
Okay.
Sir, if they ask us about bonding, if they're asking us if a molecule has this bonding, how would we tell if they're asking about the normal bonding or intermolecular forces bonding? Will they specify it?
Yeah, they will obviously specify it. Or otherwise, I will tell you one more thing. Hmm, I haven't mentioned it over here. Yeah, they will for sure specify it, or otherwise you have to understand this. Whenever they ask you, uh, uh, about the physical properties of the substance, right?
Hmm.
So remember, basically physical properties depends on the intermolecular forces. So if
Okay.
they ask you why there is a difference between the physical properties, the like the melting point and the boiling point or the state of the two different substances, then it
Hmm.
means you have to explain it in terms of intermolecular forces.
Okay, sir.
Okay. I have to explain you two things over here. For example, in permanent dipole, as I have given you the example, we have a one HCl molecule. And we have another HCl molecule. As the two atoms has a different electronegativity, so as a result, this chlorine end of the molecules becomes partial negative and the hydrogen end of the molecule become partial positive. That's why we call them, they have a permanent dipole, right?
Yes, sir.
So when these opposite positively charged parts of the molecules start attracting each other, we call it permanent dipole forces. Is this clear?
Yes, sir.
Okay. Now, what happens in induced dipole forces? And we are calling it temporary dipole forces or induced dipole forces. You have to understand the concept, how they develop. For example, there is a one atom and there is another atom, or the two molecules. As they have a known net dipole, so what happens to the electrons? That the electrons are arranged uniformly in all
Sir, I
directions.
can't see anything on the screen.
Sorry? Yeah, my screen is got stuck.
I can't see anything on the
Yeah,
screen if you're drawing it.
1 minute. 1 minute. Yeah, I was trying. See, the electrons or the negative charges are uniformly distributed. That's why it doesn't have any dipole, right?
Yes, sir.
Okay. So right now they are apart from each other. Now think, when they come closer to each other, what will happen?
Repulsion because of the negative charges.
Very good. Repulsion because of the negative charges. So see, as a result, what will happen? That these electrons gets moved towards there. And as a result, the nucleus of the first atom on which is on the right is exposed and it start attracting the electrons of the other atom, right?
Yes, sir.
So its electron also gets arranged this way. Now see, I do it like this. So this part of the molecule becomes negative and this part is
Yes, sir.
become partial positive. So see, the dipole is induced when they are get separated. They again the electrons get new that get uniformly arranged, and there is a no net dipole. But when they come closer to each other, due to the repulsion, this happens, and they get the induced dipole in them. Is this clear?
Yes, sir.
So now what will happen? That's why we call them induced dipole force. Now, but if this happens, then there are three possibilities, three more possibilities. So over here, there is going to be attraction, right?
Yes, sir.
Then, as you know that the electrons are mobile, right? So during
Yes, sir.
they are continuously moving. So at a point, this will also happen that both the negative charges comes in front of each other, and as a result, what happens? Repulsion, right?
What do you mean by in front of each other?
See, the electrons are actually mobile, they are circulating. Actually, my screen is sticking. I don't know why the internet is not working properly. Let me reshare it. It is loading.
Okay.
Now it is stuck again. My screen is still stuck on your side.
No, sir, it's working.
I'm moving the screen. Is it moving at your side as well?
Right now, yes, a little bit. It's glitching.
Yeah, there is a. So see, there we got the two faces. Now, when these two faces oriented in this way, we will observe attraction between the atoms or between the molecules, right?
Yes, sir.
But when they got oriented in this way, I'm again, it is a struct. Yeah, this way. So you will, what will observe, a repulsion would observe, right?
Yes, sir.
Then what will happen next? That they arrange in this way.
There's attraction again.
There is a attraction again. And so after the dipole is induced, the two atoms are continuously moving, and as a result, they are making all these four faces. So there is a continuity of a repulsion and attraction, right?
Yes, sir.
So that's why we also call it temporary dipole forces.
Okay.
So why we call it induced dipole forces, or why we call it temporary dipole forces? I think now it is understandable, and that's why it is, observed between the molecules which have known at dipole.
Okay, sir.
Is this clear?
Yes, sir.
Okay. So we are done with these factors.
Yes, sir.
Okay. Now we have a property of water due to the hydrogen bonding between its molecules. So Water basically shows anomalous properties due to the hydrogen bonding between its molecules. The first anomalous property is its high melting and boiling point. If you see the other elements of this group, so as oxygen is forming water with the hydrogen, the other elements also form the same compound with the hydrogen.
Yes, sir.
And all of them is going to be the same shape bent.
Yes, sir.
It means they are all going to have a net dipole.
Yes, sir.
And then it means, see, it has a 10 electrons, it has a 18, it has a 36, it has a 54. So the number of electrons increasing. So if the number of electron increasing downwards, it clearly indicates that the intermolecular forces would going to be increased downwards, right?
Yes, sir.
So it means on the basis of this, this one must have a highest boiling point and this one must have a least or the lowest boiling point, isn't it?
Yes, sir.
But the thing is that as, okay, between these molecules, which kind of intermolecular force is there?
Hydrogen bonding?
Between these
No.
molecules. Permanent dipole-dipole forces as they have a net dipole.
Yes, sir.
But in this, it is a hydrogen bonding, and due to this, see, its electrons are only 10. But when we see its melting and boiling point, it is going to be the highest. It is even more higher than this one. And the trend the factors which we discussed, we are going to observe that trend in these three only, because these three have a permanent dipole-dipole force, same intermolecular force of attraction, and the number of electrons are increasing. In the same way, what do you understand by the term enthalpy change of vaporization or enthalpy of vaporization? What do you understand by this term?
It is change in energy because of vaporization.
Yeah. Very good. So we can say the amount of energy needed to vaporize, or how much amount of energy is needed to vaporize a substance. So vaporization leads to the change in the physical state.
Yes, sir.
So it means when vaporization occur, which bonds are broken? Covalent bonds or intermolecular forces?
Intermolecular forces.
Very good. So now if we able to get the amount of energy of vaporization, we are able to know which one has the strongest intermolecular force.
Yes, sir.
So when 1 mole of each of these substance gets vaporized, their amount enthalpy change of vaporization is recorded, which is like this. See, water needs most or the highest amount of energy to vaporize. And it is why?
Yes, sir.
Because it has a
Because of
hydrogen.
hydrogen bond.
And from here to H2S to H2SE and to H2SE to H2TE, it is increasing because the number of electrons are increasing. So we are going to observe a proper trend because they all have a same kind of intermolecular force, which is permanent dipole-dipole. But as it has a lowest number of electrons, so it would have the lowest enthalpy change of vaporization, but it has in actual the highest enthalpy change of vaporization because of hydrogen bond. Is this understandable?
Yes, sir.
Okay. Now, the next thing, water has a high surface tension due to hydrogen bond between the water molecules. For example, if you have a very small tube, when you fill oil in it, you will feel the layer, the upper surface of the oil like this. But when you fill the water in it, you always observe
Yes.
water to be filled the upper surface like this. It is, pulled towards the, base or the bottom. It is because of hydrogen bonding. So that the hydrogen bonding is so strong so that it is the molecules are attracting each other so strongly. As a result, we will get this kind of a shape of a curve or the meniscus of water. Is this clear?
Yes, sir.
So see, that is called high surface tension. Because of high surface tension, the meniscus of water would be like this instead of being this. Is this clear?
Yes, sir.
Okay, now next one. In ice, see, this is another anomalous behavior. Water molecules, when arranged, so what happens in ice, they arrange themselves in a three-dimensional structure, right? Because ice has a three-dimensional structure, right?
Yes, sir.
So what happens that instead of getting closer to each other, water molecules gets further apart. Normally, what happens when a liquid turns into solid, molecules or the particles come closer?
Yes, sir.
But in water, the molecules gets further apart. And that makes ice is less dense than water. And we have a proof for that. For example, if you have a ice, if you have a water or if you have a soft drink, when you put ice in it, what happens to the ice? It floats or it sunk to the bottom.
Floats.
So what that floating indicates me?
It's less dense than the liquid, less dense than water or soft drink.
Is this understandable?
Yes, sir.
Any questions still here?
Mm, no, but if the molecules in ice are far apart, how are they even forming a solid?
How?
How are they even forming a solid?
Okay. I'll try to show you one thing. Yeah. Okay. I have a one link which actually shows that when they are closer to each other. Okay. Uh, just give me a minute. I will try where if I will get. Okay. Till then, I have one question for you.
Yes, sir.
Now, you also understood that why that yes, ice is less denser than solid, right?
Yes, sir.
And it clearly make you to understand that in solid, if it's less denser than water, it clearly means that the particles are further apart, isn't it?
Yes, sir.
So in other substances, we exactly observe the opposite of it, that when the solid forms, the
Yes.
particles get closer than the liquid,
Yes,
right?
sir.
So can you
Yes.
think of the significance that why it's different in water? What will be the significance of this opposite phenomena in water?
Because of hydrogen bonding?
No. Yeah, it is due to the hydrogen bonding. That's right. I'm not asking the reason. I am asking the significance of this opposite. Why, why it's the opposite phenomena makes it. What is the importance of this thing?
Mm. I don't know, sir.
Think, try to think what. Okay, now I see. Basically, it is very important. Why? For the survival of the aquatic life. For example, if ice would be more denser than salt water, then what would happen whenever the temperature in the winter drops to zero or below zero? The sea or the ocean or the lakes or the rivers, they start freezing from the bottom, and they got freeze and become solid from the bottom till the surface, and as a result, whole aquatic life destroyed. So what we see that when the ice forms, ice being a less denser, it directly floats to the water. And in winter, the colder regions have only the layer of a ice on the top of the river or on the top of the lake. And beside this layer, the water is in the liquid state and it's flowing, and all the aquatic life survive.
Yes, that makes sense.
So that's why you know that Allah makes this phenomena in water to keep all the aquatic life alive. Otherwise, the aquatic life would not be, uh,
Surviving.
yeah. So let me try to show you this. I'm see that's what it is. We keep it over here. So now have a look. Now you will see the comparison between the water molecule in solid and in liquid. So in liquids, they are not attracting each other in a regular or uniform pattern. As a result, they get closer to each other. But when the solid ice is formed, this water molecule, C, is getting attracted from this, from this, from this, from this. So as a result, when each water molecule is getting attracted from four different sides, which makes them get separated from each other. And as a result, when they form a uniform lattice, the particles get further away. But in the liquid state, as there is no proper attraction between the particles, so they are irregularly arranged Due to that irregular arrangement, they come closer to each other. That
So,
happens.
sir, in
Yeah,
the water molecules in liquid, they do not have hydrogen bonding.
they do have a hydrogen bonding, but the number of hydrogen bondings are lesser.
Okay.
But in solid, there are more number of hydrogen bonding. For example, this water molecule is getting attracted by this one, but these two are not attracting this water molecule. But here, each water molecule is attracting from 4 sides, and as a result, that each water molecule is getting attracted from 4 different molecules, which make them to get separated and a little away from each other.
Okay.
Okay. And what was the initial heading of this thing? Anomalous behavior, right?
Yes, sir.
So see, that's what is anomalous, isn't it?
Yes, sir.
Any questions?
No, sir.
Okay. Now, these kind of questions usually come in the paper. So I am going to explain you one structure, and then I will ask you to draw the rest on your own and show me, okay?
Okay, sir.
So what examiners do, examiner normally ask you to show the hydrogen bonding between molecules. So what you have to keep in mind when an examiner says so, let's try one example, then the next one you will try. So what were the conditions? Can you recall for the hydrogen bonding?
That the bonding should be between hydrogen and fluorine, oxygen, or nitrogen.
Of 2 different molecules, right?
Yes.
Is there any other condition for the hydrogen as well?
No.
Yes, there was. Let me add it over here. This hydrogen is bonded to fluorine. This hydrogen is bonded to nitrogen. This hydrogen is bonded to oxygen. Hydrogen can bond it to chlorine. Hydrogen can bond it to carbon. Hydrogen can bond it to sulfur. Hydrogen can bond it to bromine, etc. So as you say, see, they all usually have an electronegativity difference, which makes this hydrogen partial positive and this part partial negative, right?
Yes, sir.
Same happens over here. Okay, in hydrogen and carbon, we consider it's relatively very close. So there is another molecule, for example, over here, which contains a fluorine or oxygen or nitrogen, and all of them have a lone pair. If this fluorine is attracting this hydrogen or this hydrogen or this hydrogen through lone pair, then yes, this is the example of hydrogen bonding.
There should be a lone pair present.
Yeah, obviously, if fluorine, chlorine, and nitrogen attract, they would attract with the lone pair. Okay.
Okay, sir.
So yes, there is a hydrogen bonding present. Okay. Now in
Okay.
this case, these hydrogens also there is a one molecule which has fluorine, oxygen, or nitrogen and a lone pair.
Mm.
And from lone pair, this fluorine, oxygen, or nitrogen attracting these hydrogens from the other molecule, right?
Yes, sir.
So this is not considered as hydrogen bond because hydrogen,
Because the second molecule doesn't have the nitrogen, oxygen, or fluorine.
yeah, and more importantly, this hydrogen must be covalently bonded with the fluorine, oxygen, or nitrogen. And if only that kind of a hydrogen is if attracted by nitrogen, oxygen, or fluorine, then that attraction is called hydrogen bond.
Okay, sir.
Now, is it clear?
Yes, sir.
So basically, there are two conditions. One is that in a molecule, hydrogen is bonded to a chlorine, nitrogen, or oxygen first. And that specific
Fluorine,
hydrogen is,
oxygen,
for
oxygen.
example, let me give you another example. I have a alcohol molecule, right?
Yes, sir.
So in alcohol molecule, there are 4 hydrogens, right?
Yes, sir.
Now, if this hydrogen is actually attracted by another molecule having fluorine, oxygen, or nitrogen with a lone pair, then this is called hydrogen bond.
Yes, sir.
Okay. And if this hydrogen over here that is bonded to carbon is attracted by the lone pair of another molecule of fluorine having a fluorine, oxygen, or nitrogen, and that fluorine, oxygen, or nitrogen attracting this hydrogen, it is not hydrogen,
Not a
it is
hydrogen
a
bond.
van der Waals force. Okay.
Yes, sir.
Now is it clear?
Yes, sir.
Any confusion?
No, sir.
Okay. Now, so yeah, I want to show you the diagram how to make. So what you will do, for example, first you make a one water molecule. Let me draw it like this. So in water molecule, for example, if I am considering this oxygen is going to form a hydrogen bond, right?
Yes, sir.
So I will draw another water molecule in such a way that its hydrogen which is bonded to oxygen must facing this oxygen. Okay.
Yes, sir.
Okay, so oxygen has 2 lone pairs. Oxygen got partial negative, hydrogen got partial positive, right?
Yes, sir.
You have to make the dipoles in the diagram as well. This diagram normally come for 3 marks. Now see,
Okay.
this oxygen is attracting the
Sir,
hydrogen. Yeah,
won't that hydrogen be positive? The one on the lower right?
yeah, it's positive. Sorry, my bad. So hydrogens are going to be partial positive and oxygen is going to be partial negative. So this green line represents which intermolecular force?
Hydrogen bonding.
Hydrogen bond. In the same way, the green line from the lone pair of the second molecule to the hydrogen of the first molecule, which is actually bonded to a oxygen, is also considered as a
Hydrogen bonding.
hydrogen bond. Is this clear?
Yes, sir.
Okay. So did you draw this?
Yes, sir.
Okay. Now try to make and show the hydrogen bond between ammonia molecules.
NH3, right?
Yeah.
Sir, I've sent you the picture. Is this correct?
Let me see. Yeah, it is correct. And you can draw it by in this way as well. But the way you made it, it is also correct. In this way, we are showing two hydrogen bonds. Oh, sorry. The way I
Yes,
have
sir.
shown here, it's showing one hydrogen bond, and the way I have drawn earlier, that shows two hydrogen bond, and in the diagram you have shown two hydrogen bond. So that's fine as well. So you can draw this way or this way, both
Okay, sir.
considered as correct, okay? But the thing is
Okay,
that,
sir.
yeah, that's fine. Okay. But you try to make in ammonia, try to make in this way, that would be preferred, okay?
Okay, sir.
If I ask you to draw the water molecule, show the hydrogen bond between ethanol and water molecule.
Okay. Ethanol formula is
Ethanol, okay, or you can make it methanol. Methanol is CH3OH.
CH3. Oh, sir, I've sent you.
Yes. Very good. Perfect. Now, between hydrogen fluoride molecules,
Sir, I've sent you.
hydrogen fluoride, you did a mistake. First, how hydrogen make two bonds.
Oh, sorry.
Otherwise, the way the hydrogen bond between the fluorine of one molecule and hydrogen of other molecule is correct. But hydrogen fluoride is HF like HCl, right?
Yes, sir. Sorry.
And between ethanol molecules, we can show it this way. You have
Yes.
drawn between water molecule and methanol. So it can be drawn by this way as well, CH3OH, and then H of water molecule, O and H. So this is partial negative, this is going to be partial positive, this is partial negative, this is going to be partial positive. I'm going to put two lone pairs like this. And then a dotted line from the lone pair to the partial positive hydrogen, which is covalently bonded to oxygen to show the hydrogen bonds. Is this clear?
Yes, sir.
Okay. Now, do hydrogen bond can exist between this and water?
No, sir, because the oxygen has no lone pair.
No, oxygen. See, that's what I have discussed in the last class as well. Sometimes we don't show, the examiner also don't show the lone pair, but see, oxygen is forming two bonds only. So it means this oxygen has two lone pairs, and this oxygen is a water molecule, oxygen of a water molecule, which also have a lone pair of electron with it. So you have to
Okay.
see. So
But
the lone pair are
the
there.
oxygen isn't directly bonding with hydrogen.
Okay, but that is the condition for hydrogen. So in this case, the hydrogen bond would be observed, but in a specific manner. For example, if I say this molecule and I ask you, do hydrogen bond exist between these molecules only?
No.
No, because hydrogen is not bonded to oxygen, right?
Yes, sir.
Okay, but in water, hydrogen is bonded to oxygen, right?
Yes, sir.
So it means, if have a look at this, we have a methanol, oh sorry, it's ethanol aldehyde. And here I have a water. So this partial negative oxygen with its lone pair attract this hydrogen of a water molecule, and that hydrogen is covalently bonded with the oxygen. So this is hydrogen bond, isn't it?
Yes, sir.
Understood?
Yes, sir.
So this is hydrogen bond. But if the oxygen of a water molecule, although it has a lone pair and it is partially negative, attract this hydrogen, this is going to be considered as a van der Waals force.
Because hydrogen isn't connecting with oxygen floating in
Yeah,
nitrogen.
very good. So that is the actual concept. So it is very specific.
Okay, sir.
Now is it clear?
Yes, sir.
So we are done with the intermolecular forces. Now see
Yes, sir.
the properties of the covalent substances with simple molecules. We have discussed all of them are simple molecules. So most of the simple molecules are gases and liquids, and very few are solid. They have a low melting and boiling point. They have a low enthalpy change of vaporization. They have a low density, and all of them is because there are weak intermolecular forces between the molecules. So less energy or less amount of energy is needed to break these intermolecular forces or overcome these forces. Is this clear?
Yes, sir.
Okay, now if I categorize simple molecules, we did it in the yesterday's class that there are two types, one having a net dipole which are polar and the other having a no net dipole which are non-polar. So on
Yes,
the
sir.
basis of solubility polarity, they are soluble in water, they react with water to form ions. This reaction is called hydrolysis. So see, the one which like HCl is a polar. So they are soluble in water, and how they are soluble in water? They react, they don't just dissolve in water, they actually react with water, and we call that reaction a hydrolysis.
Okay, sir.
Beside this, the one which can form hydrogen bonds with water molecule, they are also soluble in water. See, this can form water molecule, hydrogen bond with water molecule, right?
Yes, sir.
So this is water soluble, but this will not react with water, okay?
Yes,
Because
sir.
it is forming the hydrogen bond. The other polar one which do not able to form a hydrogen bond, if they dissolve in water, it means they dissolve by the reaction hydrolysis. Is this clear?
Yes, sir.
Okay. The one who have net dipole, no net dipole, these are not attracted to the water, hence they are normally insoluble in water. If any one of them gets soluble, so it is also by some reaction as well. Now, the next property, simple molecules do not have any mobile ions or mobile electrons. So they do
Yes,
not
sir.
conduct electricity, but some simple molecule form ions when they're in their aqueous state. So it means when we dissolve them in water like HCl, HCl have no ions, but when it get dissolved in water, it forms ions in the aqueous state. So in their
Yes, sir.
aqueous state, it can conduct electricity.
Okay.
Is this clear?
Yes, sir.
Anything else still here you want to ask or any query?
No, sir.
Okay, so there are a few more things about the orbital overlapping and the hybridization, which we will be doing inshallah in our next class tomorrow.
Okay, sir.
Okay, so see you inshallah tomorrow.
Yes, sir.
Take care.
Inshallah.
Goodbye. Allah Hafiz.
Allah Hafiz.